Okay, here we go. And now. Okay, thank you everybody for joining. Thank you so much for joining. Hello. Okay. For those of you that are just joining, thank you so much for joining. My name is Lynette. I've been teaching Abacus for about 20 years now, and we have me. We're waiting for you people? No, we're going to keep going. So for those of you that just started, we are going to learn how to read the abacus. Here is my trusty abacus. This abacus is a counting tool. It helps you visualize your numbers. That's what it does. We are going to learn how to count. There we go. Okay, so for those of you that are still here, we're going to count on the abacus. We have our beads. There's the top beads, and then there's the bottom beads. The top beads a value of 5, the bottom beads a value of 1. So we actually have 1, 1, 1, 1. There's 4 ones here, so this is 4. This is 1, this is 2. There's 2 beads here, there's 3. Because there's 3, we can do 4. That's what 4 is. And then we have 5. The top bead will always be 5. The top bead will always be 5. We have 5 plus 1 is equal to 6. We have 5 plus 2 is equal to 7. 5, and then there's 2 beads. That's what 7 is. We have 8. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. If anybody is interested in workbooks, I do have a few workbooks available. I do have a few workbooks available. If you're looking for something to read the abacus, I have a 4-digit number. I also have a 3-digit, as well as a 2-digit. So we have our 3-digit, our 2-digit, our 3-digit, and our 4-digit. There we go. All right. We're going to bring on some people. Thank you so much for joining. Thank you so much for joining. Those are my, okay. So, hello, Alyssa. It's just you and I because Tammy couldn't make it.
Okay, that's totally fine. I'm gonna change my name
Okay.
because but yeah, that would be totally cool.
Yeah.
Yeah.
Yeah, she's having some physical problems. So so she's unable to join us today.
Oh, okay. Well, I hope everything goes better for her and that she's okay.
I hope so too. I told her that I'll talk to her when I'm done and we'll just chit chat and see what happens. Yeah.
Oh, that's
It,
awesome.
you know, it kind of flares up, and so it is what it is. And so she keeps moving her fingers to deter but that's what happens. So I was just showing about everybody how to read the abacus, and I saw your email.
Yes.
Aha! What's wrong with the email? What's the problem?
Oh, is it not working?
No, it is working.
Oh, I just
Um,
kind of snapshots and pictures of
yeah.
some pages um, that I really liked at the very bottom where it says complete. I re
Uh-huh.
I really like that format with the plus, the -9, the -8, and the -7, because you can really relate that to the abacus.
Oh, right. Yes, I see. Oh, right here at the bottom. Okay, got it.
Yes, I just kind of took a picture of the whole page, but my thought process for today is doing some subtraction problems. And I remember you were talking about how your sons, they went to school, so they didn't have an abacus.
Yes.
And I know that you don't really do, you know, mental math with the abacus where you thumb up, thumb down. But that's exactly what I thought of with the -9, because minus the 9 is minus the 10. Hold on a second.
So minus the 10. So minus the 10 is if minus the 9 is if I have okay, so if I have 15 minus the 9, so it's finger down and it's one thumb up. And so my final answer would be 16. So here in the question, I don't know if you could see that. I should stop. So here, what I have is, nope. There we go. All right. So we have 15 on the abacus. I want to take away the 9. To take away the 9, all I got to do, what is it that I'm trying to do? Well, before we get into that, why are we trying to do this? If I have 9 on the abacus, I'm sorry, if I have 15 on the abacus, let me do 15. 1, 2, 3, 4, 5. And then 15. 1, 2, 3, 4, 5. There we go. So I have 15 on the abacus. I want to take away the 9. If I take away the 9, notice I could take away the 9 from this 10. So if you look, this is 15. This is 10 right here, right? 5, 6, 7, 8, 9, 10. This is 10, and then this is 5. So that's what 10, and this is 5. So what we're trying to do is we're trying to take away the 9. Take away the 9, you take away the 10. So you break the 10, and then this has to be added to the ones place. So this moves up to the collective, and this becomes part of the ones. So we take away the 10 because we broke it, and we had 1 extra, we add the 1. So this becomes 6. So my final answer is 6. So we did 15, take away 9. When I do it on the abacus without the bricks, I would do take away the 10 plus the 1. So when I take away the 10, it's minus the 1, minus the 10 with my finger down, and then plus the 1 with my finger up. And that's what I would do. So here we have our number. We have 11 minus 9. So we had 11, 15, 17, 12. And then minus the 9, we can do this. So we have 11 on the abacus. That's what 11 looks like on the abacus. I want to take away the 9. What is minus the 9? Minus the 9 is equal to minus the 10 plus the 1. So minus the 10 plus the 1. And then we do it again. So we have 15 on the abacus, 15 on the abacus. I want to minus the 9. Minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. And then we have 17. So we do 17 minus 9. 17 on the abacus. 1 and then 7. Minus the 9. Minus the 9 is what? Minus the 10 plus the 1. So minus the 10 plus the 1. So my final answer is 8.
What's so cool about that is that you're seeing patterns.
Yes. Yes, you're right. That's a really good one. And so we have 12 on the abacus, and we want to minus the 9. Minus the 9 is equal to what? Minus the 10 plus the 1. Minus the 10 plus the 1. So my final answer is 3. I like that. That's a really nice one.
This week, what we did, I just plunged into it. I just took your abacus framework where
Yes.
it gives you the steps, and we just did that with the math with confidence.
Nice.
And then we also did it with Beast Academy. Avram went and grabbed his abacus and he just
Yes.
started adding.
Good.
So, and I'm having my husband do that more so than me. He seems
Okay.
to relate to his dad a little bit more. Maybe I'm too stringent.
Yeah.
But it was so cool that he was picking up the abacus and using it. And so that, hold on a second.
Okay. So we're going to continue on. We can do the 8. We can do 16, 11, sorry, 10. We want to be careful with this one.
Why is that?
Why? Because
Yeah.
it's a double, it's a
2-step.
it's a 2-step.
Oh, he actually did two-step as well.
Good. Because why? Because he knows he solidified the concept of minus the plus the 5. That's why.
Okay, I see.
Right? This is why you're gonna repeat minus plus the 5 often. That's why you don't get stuck. So we have 16 on the abacus. 16 on the abacus. I want to take away the 8. Take away the 8 is what? Minus the 10 plus the 2. So minus the 10 plus the 2.
Oh,
So my answer is 8. So here, 10, take away 2, take away 8 is minus the 10 plus the 2. Minus the 10 plus the 2. My answer is 2. We have 8 minus 14. Minus 8 is minus the 10 plus the 2. Minus the 10, add the 2. This is where it becomes automatic. That's why you don't get stuck.
5 minus the 3, yeah.
Yeah. So plus the 2 is equal to plus the 3. I'm sorry, plus the 5 minus 3. Plus the 5 minus the 3. And my answer is 6. But see, it was seamless for him. He didn't know that it was a 2-step. He just knew that he didn't have any more beads. He probably just did it, didn't he?
Yes, yes. Oh, he's almost there. Yes, he's almost quite there. Yeah.
Yeah. And that was the whole thing. The whole thing is to be able to do this without any hiccups. So that's why you just keep going, because the numbers will repeat itself. There's so much repetition in adding and subtracting that you don't have to get stuck in one.
Mm-hmm.
You know what I mean? So we have 17 on the abacus. I want to minus the 8. Minus the 8 is minus the 8 is equal to minus the 10 plus the 2. Minus the 10 plus the 2. And my answer is 9. This is really fun. I do like this.
It's just because because I'm sure you can do that when you do +8 or whatever, because they're just wrapping it around. What they're probably thinking is that you get to kind of memorize the facts. But that, when I saw that, I'm like, that is the true abacus way. You can totally
Yes.
write out your formula, and
Yes.
then you can see your pattern. Uh,
Yes. Because you're focusing on the second number. The
yes.
second number is what you need to focus on. And yes, you're absolutely right, because they're focusing on the second number.
Well, they don't realize that though.
Yeah, exactly. They don't realize it. They're thinking that they're just giving you a math fact that you have to memorize. But in
Yeah.
abacus, if you notice, this is all we have to do. Of all of these things, this is all we have to do. We have to just memorize this. It's the same thing over and over again.
I
That
just
is
think
very nice.
I just think it's a cool format.
Yes, yes, yes. It is very cool. And I will be incorporating it.
Oh, do you like it?
I do like it. I do like it. I had one like what I did, I found one with like the spin the wheel. Have you saw the spin the wheel? I thought spin the wheel was kind of cool just because it was kind of interactivity.
Yeah, in your books.
Yeah, yeah, yeah. Let me see if I can get it out. So I don't know if it's in this one. Yeah. So that's what I was thinking, like spin the wheel. But this one doesn't necessarily show you the actual pattern. Whereas this one shows you a really good pattern. Yeah,
Oh,
I
the
do
one
like
that
it.
I'm doing right now.
Yeah. So this one here really shows you the pattern, whereas this one just shows this one is just to be interactive.
Right. Right.
Yeah.
So you can create, so what you're saying is that you can put minus the 9, especially when you're doing like a 2-digit subtract. You can change those numbers. Those numbers can be any number.
Yes, exactly.
Well, and most of those numbers are like, you don't have like 13 minus 8. So how would that, if you were to do something where the number is a little bit, yeah,
What do you mean? It's the same thing. So 13. So 13 minus 8, this would be a two-step.
yes. Yes, they don't have any. Yeah, yeah. Well, I'm talking about in the format that they have right there, where they on the side there's the numbers, and then they have
Yeah.
the, yeah, like that. Um, oh, well, yeah. I
What
guess,
what
and then that's where you write the second formula right there. I
I
see.
would I would put it on the side. So what I would do is um I keep this format and I'd put the formula on the side. So they would have to practice writing the formula on each of them.
I think
But
that's probably where your one book comes. Abram has not written formulas out on the side yet.
that's okay because I didn't think that they needed to, but as I started going through, I was like, no, they need to start writing formulas because my activities are too interactive. And so I think they kind of forget. And so I realized that with one of my students, I needed to add in the extra spaces for them to write the formulas. So it's okay. I mean, it will come. It will come.
Yeah, I just think he's kind of took a leap jump. And
Mm-hmm.
I, like, for example, I was hoping that he already wrote in it, but I think because he's done a little bit of the abacus, because he was having a brain freeze, like he totally forgot how to add. And so when he started practicing on the abacus, everything started to come back to him, it seemed.
Good. Yeah, sometimes to verbalize it. So I know there's one student that I have, he knows how to do his numbers and he knows like something, right?
Mhm.
But I'll ask him, well, how did you do that? And what he would say is, okay, what did you do? He goes, well, I added the 5 and I took away the 1. So even getting him to realize what he's done would be a good exercise.
Okay, I will do that. I
You know
will.
what I mean? Just like you did it on the abacus, tell me how you did it. And just say, look how you added the 5. That's all you're doing. You're adding the 5. And it's not rocket science, but I think the kids, because the teachers, well, like the books and stuff, they make it more than it really is. But
Mhm,
we're trying to show the literal, like just add the 5. All you got to do is add the 5. You got to
mhm,
just take away the 1. That's all you're doing,
mhm.
right?
Yeah.
So,
Um,
yeah.
I was gonna say, when they do tic-tac-toe,
Oh,
you
yeah.
actually verbalize. They both
Yeah.
say it out loud. Yeah, my husband says it out loud. And so my question, that one sheet where it showed the format, where it showed you the the algorithm for the addition and the subtraction, and then doing the two digits with subtraction, because he's not quite there. I noticed on the abacus, on one of the problems, he automatically would put the 6 there up, and then he would add the rest of the numbers. uh,
Wait, what are we talking about?
I'm talking about the other sheet that I sent you. Do you
Oh, um,
I sent you three emails.
yeah. The two last ones are the same.
I meant to send the subtraction one, Allegrum. Okay. I,
Okay, so you want to take some time to give me that right now, and we can
yeah,
look
I
at
can do
it?
that. Yep.
Yeah.
Send it. Hold on.
Okay. Yeah, because I looked, I was like, huh. Okay. Um, yeah.
Okay, let me
So
send that to you.
okay, because the one that I have is this one, and this is just the addition algorithm.
Yes. Okay, so I didn't send you the subtraction one. Okay, I will send the subtraction one. I went and I took a picture of it because this is
Yeah,
okay. I'll send it to you. It's kind of sideways. Do you still want me to
that's
send it
fine.
to you?
No, send it. Yeah, that's fine. I can do it. Yep.
Okay. It's so cool. You're right there, so I can like totally send it to you. I'm sending it from my phone.
Oh yeah, nice.
So I think you got it. You can let me know if you got it.
All right.
Um, when you're subtracting, is it always good to start from the left? Or should we
Uh,
start from the right?
it's up to you. Up to you. If you want to do left, you could do left. If you want to do right, you could do right. You can, you know what? Try both. See what you feel. See what feels good to you.
Because in that, did you get it? Did
Yes.
you get did you
Yeah.
get it yet?
Yep.
Okay,
Hold on.
I'm sorry about it.
That's okay. So what's up?
So with that subtraction, because they always take let's see. Yeah, I have it kind of. Oh yeah, you have that thing that can spin it.
Yeah, that's
There
fine.
you go.
You're okay. It's good. Oh, I'm gonna attach it. I gotta do this. I like this. There you go. Yes.
Okay. So obviously, yeah.
If the top digit is greater than, if the top digit greater than or equal to the bottom digit, can you trade? Uh, okay. What are we doing here?
Well, I think what they're talking about, so see, it says start with the ones place. So when we start in the ones place, let's do the 80 minus 47. So if the top
80. Oh, okay, wait.
minus,
So
yeah,
80 minus 47. Okay, wait.
okay.
Yep.
So they're talking about in the ones place, if that is greater than or equal to the bottom digit, if yes, then we subtract. Well, we know that the top digit is not greater, or so there's no beads, okay, in that one. So then they go over to the 4
Yep.
and they borrow 10. Or yeah, see that's so weird. Okay, so yeah, that's what they do. You have to change that to what do you have to change the 0 to? A 9?
No, a 10. This becomes 7 and this becomes 10.
Okay, okay, so then 10 minus 7.
Yep.
So my question to you is with this problem, so basically you would do minus the 7.
Mm-hmm.
So minus the 7 is minus the 10 plus the 3.
Mm-hmm.
So then you basically would put 3 on the bottom, and then you would go 7 minus 4. Oh,
Wait. Minus the
no,
10 first. So minus the 10.
minus the 10.
Yep.
Okay. I haven't done subtraction in a while. Okay.
So
Um,
then what? You take away the 4.
then you
What is
take
minus 4? Minus 4 is what? Can you take
minus the,
away? There's
minus
no
the,
room. Yeah,
yeah,
minus the 5.
minus the 5 plus the 1.
Yep, that's it. Minus the 5 plus the 1.
Okay, and then you get 38
38. Yep,
as the answer,
38.
right?
No, 30. No, 33. That moved
Oh yeah, 33.
because I'm moving it, right? So it's
Oh yeah,
33.
yep, it's 33.
So what's the difference? The difference is on a piece of paper, they cannot visualize what 10 is.
Mm-hmm.
On Abacus, we focus on the second number. So it doesn't matter. It doesn't matter. Because why? When we have 80, my question to you is, can we take away the 7? I don't have to do the subtraction algorithm. I just look at my abacus. Can I take away the 7? No, I cannot take away the 7. Well, how do you do it? I know minus the 7 is minus the 10 plus the 3. That's the difference. I don't need to have an algorithm to tell me if this is enough or not. Even if I had 81, right? That means the kids would have to require understanding what is less than 7. They need to know 1. This is not understanding the concept, but this is understanding memorizing what numbers are here, right? 3, 4, 5, 6, and then 5, and then that's it. See, it's got to be equal to or greater than. So if it's 7, so if we have 87 on the abacus, you can easily take the 7 away. We don't need to trade.
You don't.
No, because we have the 7. We just take away the 7. If it's an 8, right? If it's a 88, same thing. Minus the 7, just take it away like that.
Because it's a simple problem. So their trading is the same as our formula.
Yes. The algorithm is kind of like the formula. Because the formula says, they say start with the ones, but it's the top number that they're looking at. Oh, sorry. It's the top number that they're looking at. If the number is not greater, then you have to trade. Then you have to do this. If it is greater, then you just subtract.
So how would you show that to Abram here? Because I haven't taught him how to trade yet. I don't really want to, but I probably will.
You can if you want to. What I would do is I would keep a loose set of bricks. Hold on. Okay. So the mainstream way they do it, we'll do 80, right? This is going to get unruly. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got 8, right? But what I would do is I would keep one loose one like this.
And I'm wondering if you really need all those 8s, all those individual 10s,
You
because you only
do.
need one set
Well,
of 10 into, well, it
yeah,
depends
but
on,
what?
well, like for example, if you have like 83 subtract 7, right? So
Yeah.
you have a 10 and 3 ones, right?
A 10 and 3 ones.
Yeah, because see, 83, I see the reason why you have 8 is because you're showing that you're taking 10 from the 8.
Yes.
Okay.
So the one that the problem, this is a good stepping stone to show the quantity. It is up to you. If he understands the numbers, you may not need to know the quantity. But if you want to show quantity, you could. It's not a problem, right?
Yeah.
So what happens is, because you want to take away 7, there's no more room to take away 7. You can't take away 7 from here. You got to break the 10, move it to this side, and then take away 7. 1, 2, 3, 4, 5, 6, 7. Then you're left with 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
Mhm.
That's why. That's how I would show it.
So if you did not, let's say you were in school and
Yep.
you did not have an abacus,
Yep.
would you show on there, besides, let's say you were not going to do any trading at all, would you just basically say plus the 7 is plus the 3, so you take an arrow, or you just put plus 3 by the 0, and then you take an arrow by the 8 and you go down and just write 7, and then 7 minus 4 is 3.
Wait, I'm sorry. Are you asking if I did not have an abacus, what would I do? Or do I not have an abacus and teach the mainstream way? Those are
If
two separate questions.
if you did not have an abacus,
But you wanted to do it the abacus way?
you wanted to teach the abacus way with these numbers on paper,
Okay.
how would you do that?
Well, I would take it one step at a time. I
Okay.
wouldn't combine the two. So I would start from here,
Mm-hmm.
and we know what -4 is.
Yep.
-4 is minus the 5 plus the 1. So I would minus the 5, right? So I'm left with 4.
Mm-hmm.
Now I got to take away the 7. To take away the 7, what do? I know to make a 10, what is 7? When you have 7, how do you make a 10? You have to make it with a 3, right? So what happens with the 7? The 3 has to come from somewhere.
Yes.
So I'm sorry, we take away. So this is my 10.
Mm-hmm.
I take away 7. 1, 2, 3, 4, 5, 6, 7. I take this number and I add it to my ones place.
Mm-hmm.
That's what I would do.
Okay, so that's how you would do it.
Yeah. So if I was in mainstream, right, you could still do it mainstream way. Because if we had let's take the number smaller, because it gets redundant, right? We don't need these ones. The biggest one is the tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? We have 13.
Yep, that's what I was thinking earlier, that you really don't need those.
Yeah,
Those.
you really don't need it, but the kids don't understand you don't need it. You're thinking as an adult,
Okay,
right?
okay.
So those are two different things. So this is our place value. This is our 10. We would break it. So if I needed to, I don't know, 12 minus, so what's the question? 12 minus 7. 12 minus 7, right? What I would do in mainstream is I would take away the 7. 1, 2, 3, 4, 5, 6, 7. Do you see how there's this here? This would be added to the collective and it would be 5.
Uh-huh.
That's what I would do.
Yeah.
I had actually had a conversation with a friend of mine, and I was showing him that what we do in abacus world is we don't focus on the top bead. We focus on the second number. The second number is is what makes and breaks what you're trying to do.
Uh-huh.
And
Yep.
it was really interesting. Like he was mentioning that I was making he's a teacher, a second grade teacher, and he's been teaching for like 20 plus years. And I showed him this
Okay.
way, and it totally made him new pathways for him, because he was like, ah, that was the mental block. Because the problem is, so let's say we have the question of 8 plus 5. Let's do addition, right? So the question was, is 8 plus 5? 1, 2, 3, 4, 5, 6, 7, 8. And then we add the 5. Well, we know to add the 5, we have to give a 5. But I have 8, and he was mentioning, if I have 8 and Alyssa comes into the room, I don't know how much Alyssa has, but I want to make a 10 with Alyssa. So to make a 10 with Alyssa has 5. I give you 10. I give you 5, so we can both make a 10, and that gives us 13.
Oh, okay.
So it's the same thing with the reverse, right? If I have 13 on the abacus and I want to take away 6, you got to break this 10. 2, 4, 6. You got to add it back to the collective of ones. The problem with this is that you don't see the place values. So you don't understand, right? That's the difference. Here is the tens. Here is the ones.
Mm-hmm.
So using the bricks is a little bit difficult as well, because it doesn't show place values. So when we do it, it's what was it, 16? It was 13. It was 13, right? And so what happens? Just because we break the 10, you still need to move this up to the collective of ones. 1, 2, 3, 4, 5, 6. So I take away the 10 and I take away my 1 beads.
Oh, okay. I think I see what you're saying.
Yeah. You still need to break the 10 to collect what you need. But in mainstream, they do it a different way. So they combine the two. So what they do, so if we did we'll do 73. We'll do 73 minus 6, right? So what happens is, you're right. We only need to do the 2, but the kids don't understand that they have to break this 10. So if 7, right? 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, and then this is 7. 2.
But when they're crossing the 7, they're not really breaking. Because they have to transfer it over to the other side.
Yes. Yes. So what happens is, this is my 10s. This is my 1s, right? They have to break the 7 to make it a 6. So this becomes 6. There's 6 10s, but now I've broke, right? So now I have 13. And then they take away 6. 1, 2, 3, 4, 5, 6. So then you're left with 1, 2, 3, 4, 5, 6, 7. So then you're left with 7. And then you bring this down to make it 6.
Yeah, they have to that 10 has to become all 1s.
Yes. So in mainstream, the 10s has to become 1s, but in Abacus we don't.
It just makes so much more sense because you're using your partners to 10 right there.
Mm-hmm.
Because you've been learning all through kindergarten what your partners are to 10, what your partners are to 5. So utilize that, because see, when you cross that 7 and you change it to a 6, then what you do honestly is
You're counting up.
Yeah.
Yep.
Or you
So,
like the -6 is the minus the 10. You did that by crossing out the 7 and turning it into a 6. But then you have to balance, and so then you have the 4.
yes.
So then you have 3 plus 4 is 7. And so, but I just don't know how to. You're adding so much more just to subtract only 6.
Yes. Yes. But that's the difference between mainstream math and Abacus, because you see the simplicity of Abacus. It's not difficult, but there's a lot of strategies that they're trying to tell you. And so that's why I say they clutter up your mind with all the strategies. Whereas if you just take it down to the bare bones, we're already teaching the kids what the partners are. So why don't we utilize it?
That's what I say. Just utilize,
Yeah.
that. So
yeah.
that's what I would do. Like if I didn't, well, because see, eventually, okay, I know that you said that you don't teach never taught your children to do, like in the abacus world, like in India, and they're doing those tests, they're thumbing up and thumbing down because they're visualizing what they're doing. Like with the -6, they'd be visualizing, okay, in my head, I'm going to be subtracting a 10 in the tens place, and I'm going to be thumbing up 4.
Yep.
Know that at 7. Now I don't know how they do a multiple, where they do 3-digit. I don't know how they're doing that.
It's the same thing. It's the same thing. Even if you did 3-digit, it's the same thing. Why? Because you're only working on 2 numbers. You're only working on 2 numbers.
Yeah, but their brain is going so fast.
That's all about practice.
Because you're doing the formulas over and over and over and over again.
Yeah. So if it's a 3-digit number, it's the same. It's the same. It's exactly the same. Right? So that's the thing. American math makes it more complicated than it really is. It's not. It's the same thing. What are we going to do? We only look at this number. You only look at one number at a time, right? One column at a time. I gotta figure this out. There we go.
I wonder if these numbers, cause see, in Avram's book, they would actually go and put a box around that and a box around the next one and a box around the next one. And then on the bottom, they would have 1, 2, 3 boxes or something
Yeah,
like that.
yeah,
Like even when you do 7 plus 5, you have a line and then you
like
have
this, right? They have the boxes at the bottom.
they have that box, yeah.
Yeah,
Because they're knowing they know that this problem, well, especially if it was addition, it would have three places like that. Um, and so there you see that you're working with one column at a time with the way that they have that format.
yeah,
I lost my train of thought as to why I got there, but the same on your thing right there. Um, Yeah, because you're already making compartmentalizing each column at a time.
yeah.
So
Because
like, should I do that? Like when Abram's doing this subtraction problem, should I put a box around each individual one, or do you think he'll just know what to do after practicing so many times?
he'll just know what to do after practicing so many times. The reason why the reason why mainstream does these boxes is because they don't have anything to help them with place values. We have the abacus to help you with the place value.
Uh, because this is
Paper.
paper, one dimensional. You're seeing,
Yeah. They're
okay.
trying they're trying to get you to understand place values in this thing,
Oh,
right? That's
and
what they're trying to do.
and the abacus already does it.
Yes. See, with the place values, we have
And then
6, 4, 2. Oh, go back to the other one. We do 80, we have 0. We want to take away 40, we want to take away 7. Take away 40 from here, minus the 4, minus the 7, minus the 10, plus the 3. I don't have to tell you that this is the ones and the tens. I don't have to draw it out. You just work it on the abacus. The abacus is your counter. You need to know how to use it. So even with the 3 digit, we have 642. I want to take away the 3. Cannot take away the 3. What do I do? Minus the 5 plus the 2. We
two.
go to the next number. Minus the 9. Cannot take away the 9. Minus the 10 plus the 1. Cannot plus the 1. Plus the 1 is plus the 5 minus the 4, right? And then take away the 6. Cannot take away the 6. Minus the 10 plus the 4. Minus the 10. Can't do it. Minus the 10, right? Minus the 5 plus the 1. And then plus the 4 plus the 5 minus the 1. So we don't have to do the boxes because the abacus does it for us.
I see.
Yeah.
Okay. Because, okay, so that's why even with those simple 2 digit, well, you're doing it here anyway. Yeah.
Yeah.
Okay.
Yeah. Because if you look, you're only ever using 2 digits at any given time.
Mhm.
You're never doing 3 digits
No, you're not. You just move,
ever.
or you just move over, especially
Yes.
from left to right. Sorry, right to left. You just work that. You move over.
Yeah. I mean, we could do it the other way, right? We could do 6, 4, 2. We want to take away 6. Take away 6 is minus the 10 plus the 4. Plus the 4 is plus the 5 minus the 1. All right. That means we got to take away the 9 over here. Take away the 9 is minus the 10 plus the 1. And then we got to take away the 3. Take away the 3 is minus the 5 plus the 2. So the answer is the same. It doesn't matter which way you go. You just got to track your numbers.
Mhm.
I suggest go both ways just to see what makes it feel better for you.
Okay. Okay. Yeah. Because his book that he's doing, it's a lot of it is review, but it's jumping right into adding two digit sums and subtracting 2 digit. So it's going straight into there.
Yeah, but it
But
gets interesting. Yeah, because they'll be like, oh, you have this number here. It's a little difficult. You're gonna round up or round down to make it a friendly number. You could do that, or you could just take it for what the bricks that you have, the elements that you have, which is minus the 7, minus the 5, and minus the 2. You know what I mean? So like here, it would tell you what?
oh, yes. Okay, so but go back to that problem again.
Yeah,
So the 2, 8, 3. So the only hook hiccup you have is the minus the 7 there, right? Because you minus the 7 is minus the 10, so you minus,
yeah,
no, let's just do
yeah,
it.
yeah. No, you're good. Go on.
Okay, I got
Minus the 7.
minus the 7 is minus, I gotta put it on my 83. Okay, and I'm putting 257. So we go 3 minus 7. I cannot minus the 7, so I have to minus the 10
Yeah, plus the
plus the 3.
cannot plus the 3.
I cannot plus the 3, so we plus the 5 minus the 2.
Yep,
So now there's
minus the
6. Yeah,
5.
and there we go. Then we go 8 minus 5. That's easy.
And not 8 minus 5, it's 7 because we already took away the 10.
Right. So,
Right?
oh yes,
So
yes,
like,
it is 7. 7 minus 5. So you
yep,
minus 5.
yep,
And then 2 minus 2 is you take
yep,
away the 2.
yeah,
So it gets 26.
yep.
Oh, okay.
But we're trying to unlearn what we learned when we were kids. And they made it really complicated really quick when we were small. And so it comes overwhelming when we start doing things. But when we do it the abacus way, it's a lot easier and it simplifies everything.
Mm-hmm. Yeah, I
Yep.
see. Yeah, because you take the 8, you already know that the 2 minus 2 is going to be minus 2 anyway. And then you
Yeah.
take the 8, you change it to a 7, and then put the 1 in front of the the 13th, then 6, and then you have the 2,
Mm.
26.
But see, we don't have to memorize that 6 and 7 is equal to 13. That's a fact family that they have to memorize. But in abacus, we don't memorize fact families of 7.
No, because we do the partners to 7.
Exactly. Exactly. And so that was one of and I showed you, there was that one where I made out. Hold on. Let me see if I can find it. Um, yeah. I don't know if I showed you this to you, but like you have to memorize how to make. Yeah, I showed this to you. I remember that.
Yes, you did. You did show that to me.
And so that was the thing to memorize. You had to memorize 13 is equal to 4 and 9. 15 is equal to 5 and 6. You had to memorize the fact family of 9. And I know this because I was talking to I was reading up on other people who does what do you call it? Like on YouTube and stuff, and they explain it. And like you got to memorize your your fact family of 9. I'm like, why? We don't need to. In abacus, we don't need to because we have the fact family of 10 and we know the complements. That's the difference. We don't need to do all this memorization. That's a lot of memorizing. So don't forget, if you do it for 9, you got to do it again for 8. You got to do it again for 7. You got to do it again for 6. There's a lot to memorize, and we don't have to. In abacus, you just need to know your combination because they are worried about the top number. Abacus only worries about the bottom number. We only worry about the bottom number. The bottom number is what dictates what we're going to do. That's the difference.
That makes sense. That makes
Yeah.
sense.
It
So,
was so strange when I was talking to my friend about it, and he was like, why does that, because he's been teaching, because I mean obviously he has other things to teach, right? So me going deep diving on this, it really made him like understand we don't work with the top, we work with the bottom and we go down, so it's like a running total like this. We go from top down. We don't go up and down. We go top down like a running total. Does that make sense?
Yes, it does.
Okay.
So that example, did you put that in your book at all? Or
Which
did,
one? This one?
yeah, that one right there.
No. No, because I'm not teaching the difference between mainstream math. I would feel like that would confuse the kids.
So what you would say is that instead of worrying about the top, we're just going to worry about the bottom number, and the bottom number has to do with your partners to 10.
Yeah, that's already part of the teaching.
It's already
That's
part.
already, yeah. I'm just telling you explicitly as a parent and as a person going through it. But the kids know, can you do it? No. How do you do it? They all know to go from the bottom, from the bottom number. That's not something I have to tell them.
Oh, okay, okay. So you just created this as an example of what mainstream does, and
Uh-huh.
just how to simplify it is just basically because my question is with subtracting, because like I said, they get really, really overwhelmed because they see that 9 and it's a big number, but
Yep.
really it's not. You're
Nope.
23 minus 19, and then you're just basically minus the 10 plus the 1.
Yep. Yeah. But see, the difference is the kids don't need this sort of explanation because they don't know anything, right? I'm teaching parents and I'm teaching adults what's the difference between mainstream math and abacus math. That's why I made this. This was meant for people who have already a background. So if I'm teaching a teacher, I would show them this. If I'm teaching a parent, I would show them this. I would not show the kids this because the kids don't know this. They don't know that they need to memorize 4 plus, and they don't understand the ramifications. That what they will do is they will understand and memorize minus the 9 is equal to minus the 10 plus the 1. Because if I give them this information, then it gets too confusing. You're just giving them too much information, and we don't need all that information. Because if they just understand this, then there's no point of memorizing this, and they won't understand why this is taught.
I'm not sure if Abram knows that you have to just the focus is on the second add-in yet. He's just doing it.
It comes
So,
naturally to the kids.
okay. Okay,
They
that
don't, because it's part of the teaching. They'll notice, oh, I'm adding the 9. Because even if you had the 9 on top, right? Even let's say we had I don't know. Yeah, we'll do like 29 minus 3, right? He knows not to take away from the 9. He knows to take away the 3. He knows this. Even if we had all the numbers on the top, they know already if I did 27 and then I want to minus the 3, I'm not going to take away the 7. I'm going to take away the 3. It's already part of the abacus system.
yep, and minus 3 because there's the 5 and the 2 ones, you have to minus the 5.
Yes, but the point I was trying to make was that he knows to take the bottom number to minus.
Oh, he does. Okay. Yeah, he probably is doing that.
Yeah,
I
he
haven't
is.
I haven't done too, I mean, he does those subtractions, with that running total thing, but like this right here, I think he did one like that.
Okay. That's how they do it. That's how it's being done. Which is funny, because addition, they do it up and down. Subtraction always comes from the bottom up. You
Okay.
never go from the top. Subtraction's always from bottom up.
Hmm. Yep.
That's funny. That's really funny. So in mainstream, it's funny. This is so funny. In mainstream, they're really confusing the kids. So if I showed you this one, let me see if I can find a number. Uh, Okay, no, I'm just gonna write it. So funny. In mainstream, this is why the kids are confused. Mainstream, if I did 37 plus 4, right?
Mhm.
We're doing adding again. So what they would do is they would tell the kids, make this closest to the 10. I'm like, what? Why? Because if you notice, when we do 37 minus 4, we're not making this closest to this 10. We're using this one. But in mainstream, they go up and down. Whatever the biggest number is, they make this to a 10. So it gets confusing. Ah,
Where do you see this at?
this
Online?
is yes, this is one of the things. This is one of the practices that the teachers are doing. They're like, oh, this is 37 and it's very difficult, right? So you want to make this to a 40. And you have to remember that you added 3. So then when you do whatever, then you have to take away the 3. So they're calling this friendly numbers. This is what they call new math.
Why can't you work with what you got?
Because they're trying to provide the concept of numbers and number fluency. But the problem I see here is that now
Your
you're
number
confusing.
comes from knowing your partner.
I'm sorry, say that again.
Yeah.
Say that again.
I said your fluency is already knowing what your fluency is already knowing what your partners to 10 and what your partners to 5 are.
Yes.
Isn't
So
that
here,
what
my partner of 7 is 3. But the thing is they focused on the top number. Abacus focuses on the bottom number. It's always the bottom number. That's the difference.
uh-huh, uh-huh, uh-huh,
We
uh-huh.
already do it for
Okay.
subtraction. Why change it for addition?
And there you go. It's the same. We
It's the
always doesn't
same.
matter what, yeah, it doesn't matter if you add or subtract. Well, and the reason why they do that in addition is because the top number always has to be bigger than the bottom number. And that's why they focus on that, right?
Yeah, for
Well, no,
subtraction.
not.
For subtraction, they always focus on the top number. They subtract from the top number. They always subtract from the bigger number. But in addition, they confuse the kids. That's why there's no system. Abacus, there's a system. There's a workflow. You go from top down. So if I had a bunch of numbers, 3, 4, 87, right? They do this. Abacus takes it as a whole. We do this. And this is our running total. Whatever this number is, and then you add this number to this.
So
That's the difference.
So the 34, 36, and 87, you would basically go, no, you would
30.
put 34 down, you put 3, and you put 4.
Yep.
And then we go down, and then we do, but you do
36.
We
We do 36. Add the 3, add the 6, plus the 10 minus the 1. Plus the 10 minus the 4. It's the running total. So my answer right now is 70, right?
Uh-huh.
So then we take 70 and we add 87. Add the 7 plus the 10 minus the 3 minus 3 is minus the 10 plus the 4. And then you add the 7. Add the 7. So then our final answer would be 147.
Okay.
But we take it as a whole. We don't separate our columns. That's the concept of that.
Okay. Yeah, that makes sense.
Yeah. So and just like in Excel, just like in accounting, right? In accounting, we don't take it one step at a time because there's like 100 numbers. You do running totals.
Mm-hmm. Mm-hmm.
Right? I don't understand why we were taught this. Why do we do that? Why can't we just keep a running total?
Mm-hmm.
That's the difference. We're teaching the kids different than what we're doing in real life.
Yeah. Wow, I can see why that can be confusing. Huh.
Yeah. And so then when they get into like, like when they get into like their job and stuff, or I don't know, whatever, we start changing the way we do math when we get to higher, let's say, like algebra, trigonometry, all that stuff, it becomes very different.
Mm.
Because why? Because in algebra, you go left to right. Algebra, you go left to right. You have an equation, x plus y equals to z, whatever, right? You go left to right. You read from left to right. I don't know why we're teaching the kids to go right to left.
In algebra? Mm.
In algebra, yeah. So even the orders of operation, you know what that is? Order of operations,
Yes.
right? Order of operations. What do you do first? You do exponents and powers first, right?
Mhm.
Who's first? Whatever comes left to right. Multiplication or division. Who comes first? Whatever comes left to right. Adding and subtracting. What comes first? It comes left to right. So if I did 4 times 5 divided by 2, what do? You go from left to right. I don't know why we're changing it up and adding.
Oh, and adding. Okay, makes sense. Yeah.
That's what. So I don't know why we start from the right and go left. We always go left to right. Even when you read, we go left to right.
Oh,
It's another rent.
yep. Um, I have to go,
Yes,
but
likewise.
I really appreciate this.
Yeah, no, so do I. So do I, especially since this. And I was like, oh, I don't understand why they're going up and down. So, but thank you. I do appreciate it too. Thank
Yeah,
you so much.
thank you. I look forward to next Sunday. Okay.
Yes,